All right, let's get right into it. We are just surrounded by devices that seem to do a million things at once, right? Your phone is playing music while it's also giving you directions. Your smartwatch is tracking your heart rate and showing you notifications. But here's the secret. It's all an illusion. A really, really brilliant high-speed magic trick. And today, we're going to pull back that curtain and show you exactly how it's done. I mean, really think about it. How can one little processor, just a single brain, be running engine diagnostics, managing your music, and checking the tire pressure, all at what feels like the exact same time? Well, it's not magic. It's actually a masterpiece of management. And at the very heart of that management system is this little-known but incredibly powerful component. It's the director, it's the traffic cop, it is the boss of absolutely everything happening inside that chip.
So this manager is called the task scheduler. You can think of it as a part of the operating system that has the ultimate authority. Its one and only job is to look at this big list of tasks that need to get done and decide, millisecond by millisecond, who gets to use the processor and for exactly how long. It is the absolute core of how multitasking even works.
Now, this scheduler doesn't just pick things at random. Oh no, it operates by a very strict set of rules. First, it has the power of what's called preemption, which is really just a fancy word for interrupting. It can literally stop a task mid-sentence to let a more important one run. And how does it know what's more important? Well, that's the second rule. Every single task gets assigned a priority level. The scheduler always serves the highest priority task first.
So to really understand the scheduler, you kind of have to see things from a task's point of view. For a tiny piece of code, its life is just this constant cycle of waiting and working, and all of it is dictated by the scheduler. You know, most of a task's life is actually spent waiting, but not all waiting is the same. The first kind is what you see here, the ready state. Just imagine a line of sprinters at the starting blocks, totally ready to go, just waiting for that starting pistol. They're all lined up by their priority in what's called the ready queue, and they're just waiting for the processor to be free. But here's the thing, sometimes a task isn't waiting for the processor. It might be waiting for something else, like data from a sensor. In that case, it's put in a blocked state, and it's taken completely out of the race until its data shows up. The scheduler is smart. It only ever picks from the runners in that ready line.
And then it's go time. The scheduler picks the highest priority task from that ready queue and basically says, "You're up." This is the running state. And for a very brief moment, that one task has complete and total control of the processor to do its thing. But brief is the really key word here. Because this is where the real magic happens. The illusion of doing everything at once is created by switching between these tasks so unbelievably fast that to our slow human brains, it just looks simultaneous. It's the ultimate sleight of hand.
And this switch, this incredible power to interrupt, is that key term we mentioned before, preemption. See, the scheduler doesn't wait for a task to say, "I'm done." Nope. The scheduler decides when its time is up, no matter what it's doing.
So how does this super fast switch, called a context switch, actually work? Well, it's this incredibly precise three-step dance. First, the scheduler hits pause on whatever task is running and saves everything about its progress, what data it was using, the exact line of code it was on, all of it. Then it immediately loads the saved progress of the next task in line. And finally, it hits play, and that new task picks up right where it left off as if nothing ever happened. This entire save, load, run process happens thousands upon thousands of times per second. It's just mind-boggling.
So a huge question probably pops into your head right about now. How does the scheduler know when to do all this? It isn't just guessing. It's actually tied to the very pulse of the system itself. I want you to think of a tiny, incredibly fast metronome inside the processor, just ticking away millions of times a second. This is the system's heartbeat. It's often called the tick interrupt, and on every single one of those ticks, the scheduler gets a chance to wake up and ask one simple question. Is there a more important task that needs to run right now? This constant rhythmic check is what makes the whole system so predictable and so reliable.
And his table perfectly illustrates how that decision gets made. This is a super common scheduling method called rate monotonic scheduling. And the rule is brilliantly simple. The more frequently a task needs to run, meaning the shorter its time period, the higher its priority. So you can see here, task 1 has to run every 10 milliseconds, which makes it the most critical. Task 3, though, can wait 20 milliseconds, so it gets the lowest priority. The scheduler's job is just to enforce that simple rule over and over again.
So we've seen the scheduler, we've seen the tasks, we've seen the timing, but why go through all this trouble? Why is this microscopic level of control so incredibly important? Well, it's because for some systems, being late is simply not an option.
The whole point is right here in this definition from the official standard. It's not about being as fast as possible, it's about providing a service in a bounded response time. And that phrase right there, that's a guarantee. It means the system is making a promise that a specific job will get done within a specific deadline every single time.
And this is why it all matters. In what's called a real-time operating system, like the one in your car's anti-lock brakes, good enough is not good enough. When you slam on the brakes, the task that controls them has to be the highest priority. It has to preempt the radio, the navigation, everything. It needs a guarantee that it will execute within milliseconds. This whole system of scheduling, that's what provides that life-or-death guarantee.
So this seamless multitasking that we just take for granted every day, it's really just a clever, high-speed illusion built on a foundation of rules, priorities, and rock-solid guarantees. And it really makes you wonder, right? As our technology gets even faster and way more complex, what other illusions are being built for us right now, just waiting to become our new reality?